Hello and welcome. My name is Sanjay Soni. Here is a micro-learning readiness video about Azure SQL Data Warehouse. Thank you for taking the time to join us. Now, let's get started. Hi, Kevin. How are you doing today?
Good. How about you, Sanjay?
I'm doing great. So great to have you here with us.
Great to be here.
Can you please tell us more about your role at Microsoft?
Yes, I'm a program manager on the Azure SQL Data Warehouse product team, where I've been primarily working on manageability and developer experiences with the service.
Great. So what are we covering today?
Yeah, so today we'll be covering query data store with SQL Data Warehouse. That's currently in preview, also known as QDS. We'll also cover SQL Data Warehouse recommendations and how they help customers follow best practices with the service. And then finally, we'll wrap up this part of the video showing how these two features can be used together to tune your data warehouse.
Awesome. So let's dive in.
All right, so the features and use cases query data store with SQL Data Warehouse is very similar to SQL Server. However, I do want to highlight some scenarios specifically with SQL Data Warehouse and how QDS enhances the previous query troubleshooting experience with the service. So as you can see here, SQL Data Warehouse with QDS enables you to pinpoint and fix queries with plan regressions. You're able to view queries with multiple plans, and ultimately you're able to have a much longer retention period with QDS. Previously with SQL Data Warehouse, the DMVs only had a 10,000 row limit where entries would start getting deleted. And so with QDS now, we actually have a 7-day retention period. And the previous retention period of the 10,000 limit actually was a key blocking issue for a lot of our customers. And so, and in addition with QDS now, we also have full query text. So before we only supported 4,000 character limit before it got truncated. And so now with QDS, you can have a holistic view of your entire workload that's running with SQL Data Warehouse. With QDS, you're also able to A/B test various changes to your data warehouse model, and then continuously identify and improve and tune ad hoc workloads with your data warehouse. You're able to see top hitting queries for performance tuning and see kind of the runtime statistics for each of the queries. Currently, there is no resource utilization per request, like CPU and I/O and memory, but again, we are looking into improving that experience with QDS as well.
That's great. So how do you use QDS with Azure SQL Data Warehouse?
Yeah, so that's a great question, Sanjay. As I mentioned before, the use case is very similar to SQL Server, where we also aim to have parity in terms of the experience on both platforms. So we share the same DMVs as SQL Server, specifically sys.query-store query. You have one entry in this DMV when the query text is changed. Currently, we do a hash of only the query text, which is the query tree. So this means that the two queries, if you're running two queries that have the exact same query structure, it creates only one entry. Mm-hmm. And if for any reason there's a new plan generated for any of those two runs, there is a change in the query steps, which would mean that there will be a new entry in sys.query-store plan. In runtime stats here, you also show the average, min, and max duration runtimes for each plan. And also, in the interval ID, you can limit and filter down to a specific few executions within a specific time interval. And then finally, as I mentioned before, we also have the full query text in sys.query-store text.
That's great information, Kevin. So how often do these views in QDS get updated?
Yes, that's a great question, Sanjay. So QDS is updated post-query execution. Mm-hmm. So let's dive right into how queries are executed across SQL Data Warehouse. So when you issue queries against SQL Data Warehouse, the query first goes to the control node of SQL Data Warehouse. And then after that, it goes to the engine, which also has a query optimizer. And the query optimizer interacts with the shell database, which contains statistics and other metadata for it to come up with the most optimal parallel query execution plan.
Yes.
What that plan is, it then gets executed across SQL Data Warehouse, and then post-execution, we then update all the views within QDS. So it's post-execution that when we're actually updating the views for QDS. Mm-hmm. After that, we do flush a disk every 15 minutes. Mm-hmm. The maximum storage that we support for QDS is 10 gigabytes. The retention period is 7 days, and the maximum plans per query is 200.
Great. So is QDS configured by default?
So currently right now, QDS is not configured by default, where you do have to run an alter database set command.
I see. So how much does the QDS cost?
Yeah, so that's an awesome question. So QDS is part of your regular storage billing model with SQL Data Warehouse, where it's computed as part of your data storage size. So it's rounded up to the nearest terabyte. So it's a small fraction of your overall storage bill with SQL Data Warehouse.
So thanks for this great information about QDS. Next, can you please talk about the Azure SQL Data Warehouse recommendations?
Sounds great, Sanjay. So a key investment from the team has been around self-managed data warehouse with built-in intelligence. And a quick stop in that direction is providing proactive recommendations to our customers so that they follow the best practices to ensure they maximize performance with SQL Data Warehouse. So currently here are the top 5 or 6 recommendations that we surface to the customers in our Azure portal. The first one is selecting the proper table distribution with SQL Data Warehouse. So to provide some context here, SQL Data Warehouse, we have a massively parallel processing architecture where data is distributed across multiple compute nodes.
Yes.
And with table distribution, it basically dictates how the data resides or laid out across the data warehouse. So we have replicated tables, we have round robin, and we have hash distributed. Currently today, the main thing is we want to reduce data movement and to increase workload performance. So we surface replicated table recommendations directly to the customer. And this can be a complex exercise if the customer does not have a holistic understanding of their workload. So again, this is why we're surfacing replicated table recommendations, and we are looking into extending this experience to the other table distributions as well.
So these replicated tables are usually the dimensions which are copied to each compute node?
Exactly. So each replicated table is copied to every compute node. And again, it's the idea to reduce and remove data movement operations within SQL Data Warehouse. And the second recommendation we have is detecting data skew. So data skew, it's similar to table distribution around that topic where data skew happens when you have an uneven spread of your data across the distributions, where processing of one distribution can take a lot longer than another. And so we surface this recommendation to reconsider the hash key that may be causing data skew for a lot of these tables. And you're only as fast as your slowest distribution. So this can be impacting your entire workload performance if you have data skew. The third recommendation we provide customers is provision additional adaptive cache capacity for Gen 2. So a best practice around Gen 2 is ensuring you have enough cache capacity for your workload. So we surface 2 metrics today in the Azure portal. One is cache hit percentage and one is cache use percentage. Once we see a cache use percentage hitting near 100% and cache hit degrading over time, you know that you should scale up to increase more cache capacity for your working set. So we also surface that recommendation as well in the Azure portal. And the next one is reducing Temp-DB contention. This is kind of like a very SQL Data Warehouse heavily relies on Temp-DB for a lot of things. One is
it's a classic scenario, even for databases, SQL Server too.
Exactly. And so for Temp-DB with SQL Data Warehouse, we rely on Temp-DB for internal SQL Server work tables. We depend on temporary tables for data movement operation during query execution, and we also depend on Temp-DB for just user-defined temp tables for speeding up query performance with pre-computed results, right? And so if you have a lot of Temp-DB contention, it can impact your query performance. So you want to make sure you scale or update resource class from our memory to reduce that contention. And then finally, you have creating update statistics. Currently today, SQL Data Warehouse, we support auto-create statistics. But again, it's really important to make sure they're updated because we have a cost-based query optimizer which evaluates the cost for running multiple plans per query, and it selects the most cost-efficient plan based off of statistics. So the more that the query optimizer knows about your data using statistics, the more optimal plan selection it will have, and the faster your queries will execute.
Wow, these recommendations sound great to me. So how much do recommendations cost, and how do you configure them?
Yeah, so recommendations are free, and they're automatically configured. So you can directly go into the Azure portal, and you should see the recommendations as well.
Great. So how do you select these recommendations that you need to provide to each of the customers?
Yeah, so SQL Data Warehouse, we're already fast by default, and these performance recommendations are to ensure that you get the most performance out of your data warehouse with advanced tuning. So we chose these recommendations based on what we're seeing a lot of our customers commonly do today to achieve maximum performance.
Great, good to know. So how do we deliver this to customers?
We deliver this to customers seamlessly in the Azure portal. So today, when a customer provisions a SQL Data Warehouse, we are constantly emitting telemetry data and collecting this telemetry data and running analytics every 24 hours on this. And we're surfacing these recommendations based off of what we're seeing in telemetry directly to the customer in the Azure portal.
Great. You talked about recommendations, you talked about QDS. Can we see a live demo of both, please?
Yeah, sounds good. Let's jump right in, Sanjay. All right, so for this demo, as you can see, I logged into my Azure portal. And to access your recommendations, what you want to do is go to the left-hand nav here and go to Azure Advisor. This pulls up a blade that shows you 4 categories that we have for recommendations: high availability, security, performance, and cost. Specifically for SQL Data Warehouse, we support only performance recommendations. Where we click on this category, it will show you all the recommendations that are related to performance under your subscriptions. As you can see here, I have a few SQL Data Warehouse recommendations already. I'm going to be narrowing down to replicated tables recommendations that we just discussed a few minutes ago. Clicking on this, you can see I have 4 recommendations for replicated tables and for 2 different data warehouse resources: TBCDS 10 terabytes and Sales Data Warehouse.
So are all of these dimensions, or some of them are fact tables too?
So typically for replicated tables, you do want to replicate your dimension tables.
Yes.
So as you can see here, in my Sales Data Warehouse, which I'll be using this resources for this demo, it's telling me to replicate my nation table as well.
Awesome.
Nation and supplier, right here. Okay, so now that we discovered these recommendations for replicating tables, I'll now dive into SMS so we could apply these recommendations and validate whether or not they would benefit my workload.
Sure.
So currently here, I'll be running this specific query to just determine what table distribution do I have for nation and supplier. Currently right now, they're both round robin. And I'll be doing kind of an A to B kind of comparison to understand whether or not the query will benefit from replication. So as you can see here, I'm running this query. As I mentioned before, this should produce an entry in sys.queryStore query. After that completes, I will then be running a query to determine what the most recent query ID was. Okay, so in that run, you see we have a query ID of 280. And now I will apply that recommendation to convert my round robin tables to replicated.
I see.
And from there, I want to validate that the distribution type has changed to replication. And you can see here now my nation and supplier are both replicate, right?
Based on the recommendations that we got.
Right, so I just applied my recommendation to convert both nation and supplier to replicate as the distribution type.
Okay.
Going back to the query, I'll now rerun this query to see if there's any performance gains that I received from applying that recommendation. And as you can see, that only took 2 seconds. And to use QDS, I have a query here that will return all the query IDs that had multiple query plans. And because I changed the distribution type to replicate, it should have produced a different plan. So in this scenario, and as you can see here, I have query ID 248, which generated 2 plans, the first one taking 6 seconds for my round robin table, and the second taking only 2 seconds for replicated tables. So in this kind of scenario, as you can see here, applying the replicated table recommendations reduced my query runtime by 4 seconds.
That was great. Thank you so much for this awesome demo, as well as all the information you shared about QDS, as well as the recommendations. And thanks for being here with us today.
Thanks for having me, Sanjay.
Thank you for watching this video. Learn more about this and other topics at azure.com/SQLDW.